Hello everyone and welcome back to our channel. In today's video, we're going to explore the groupBy function in PySpark, a powerful tool that makes grouping and analyzing your data easier than ever. If you ever used SQL's groupBy clause, you'll feel right at home with this PySpark feature. We'll cover everything from basic grouping to advanced aggregation so you can effectively summarize your data and gain valuable insights. Stick around as we walk through some practical examples to help you master group by in PySpark. Introduction to the group by function. The group by function in PySpark is a powerful tool that allows you to group data based on one or more columns, similar to how the group by clause is used in SQL. This function is particularly useful when you need to analyze and summarize and so on, dividing it into meaningful groups. For example, you may want to group data by department, category, or any other key column that helps categorize your dataset. After grouping, you can perform various aggregate calculations such as calculating the sum, average, count, or other statistics for each group, which is essential for gaining insight into different segments of your data. The group by function is commonly used in scenarios where you need to calculate summary metrics, identify trends, or compare performance across different categories. Whether you are working with sales data and want to find the total revenue by region, or employee data where you want to calculate the average salary by department, group by enables you to aggregate and analyze data efficiently. It provides an organized way to break down your dataset, making it easy to understand the bigger picture by focusing on smaller, logically divided sections. Using groupby helps turn raw data into useful insight by allowing you to see patterns and trends at a group level, which can then be used to make data-driven decisions. The ability to group and aggregate data makes the group by function an invaluable tool for any data engineer or data working with large data and PySpark. Basic syntax. The basic syntax for using the groupby function in PySpark is dataframe.groupb expressions. This syntax involves two key components: the columns used for grouping calls and the aggregation expressions that are applied to the group data. The calls parameter represents the columns by which you want to group your data. You can pass one or more column names as arguments, allowing you to create different groupings depending on the structure of your data and the analysis you want to perform. For example, if you are working with sales data, you might group by a single column like region to summarize data, like region summarize sales by region, or you might group by multiple columns such as region and product type to get even more granular insight. The ag expressions part of the syntax is used to apply aggregation functions to the groups. Aggregation expressions such as sum, half, count, and others allow you to summarize the data within each group, then providing key metrics for your analysis. For instance, using sum helps calculate the total value for each group, while app computes the average. You can combine multiple aggregation expressions to derive different metrics simultaneously, making group by highly versatile. This approach is similar to using group by in SQL, where you group data based on specific columns and then apply aggregate functions to those groups to generate summary statistics. Whether you are looking to calculate the total sales by category, count the number of employees in each department, or find the average value of transactions by day, the combination of group by and ag allows you to organize your data and derive insightful metrics efficiently. By using these parameters effectively, you can transform complex large-scale datasets into meaningful summaries that can be used to inform decision making and uncover trends. How it works. The group by function in PySpark operates by creating groups based on the unique values in the specified columns. When you use group by, PySpark scans the specified columns in your data frame and identifies all the distinct values present. It then partitions the data into groups where each group contains rows that share the same values for those columns. This initial grouping step lays the foundation for performing aggregations and is useful when you need to categorize data for further analysis. Once the data is grouped, you typically use aggregate functions such as sum, count, agg, or other custom aggregations to compute metrics for each group. These aggregation functions allow you to summarize the information contained in each group. For example, you might use sum to calculate the total sales within each region or count to determine the number of employees in each department. By applying aggregate functions, you can generate key statistics that provide insight into how different segments of your data compare or how they perform in various contexts. The combination of group by and aggregation functions allows you to easily break down and summarize large datasets, transforming complex detailed data into simpler and more informative summaries. This is especially useful for gaining insights, identifying trends, and supporting decision making. For instance, in a retail dataset, grouping by product category and then using some on sales data can help you understand which categories are performing best. Overall, group by provides a straightforward way to organize data into meaningful segments, while aggregate functions help you quantify and analyze each group effectively. Practical examples: 1. Grouping by a single column. In this example, we are working with a PySpark data set that contains sales data for different items. The data frame has two columns, item and sales. We create the data frame using the createDataFrame function where each row represents a specific item and its corresponding sales value. The dataset includes multiple records for some items like item ID and DIM, allowing us to perform group level analysis. To gain insights into the total sales for each unique item, we use the groupBy function. By calling the df.groupBy item, we instruct PySpark to group the data based on the item column, which means that rows with the same item name will be grouped together. After grouping the data, we use the sum_sal as aggregation function to calculate the total sales for each group. This helps us determine the overall sales performance for each unique item across all records in the data frame. The resulting data frame contains two columns, ITM and the calculated total sales, sum sales. We then use the .show method to display the output, which presents each unique item along with its total sales value. For example, item A appears in the dataset twice with sales of 10 and 30, resulting in a total of 40. Similarly, item B appears twice with sales of 20 and 40, giving a total of 60, while item C appears once with sales of 50. This example demonstrates how the group by function combined with an aggregation function like sum allows you to easily summarize data by categories. By grouping the data by item and calculating the total sales, we can quickly see the overall contribution of each item, making it easier to analyze performance, identify trends, and make informed business decisions. 2. Grouping by multiple columns. In this example, we are working with a PySpark data frame def_multi that contains sales data for different items across various regions. The data frame has three columns, item, region, and sales. We create the data frame using the createDataFrame function where each row represents an item, the region where it was sold, and the corresponding sales value. Some items are sold in multiple regions and some regions have multiple sales records for the same item. To analyze the total sales for each item in each region, we use the groupBy function to group the data by both item and region. By calling df_multi.groupBy item region, we instruct PySpark to create groups based on unique combinations of both item and region. This means that rows with the same item and region will be grouped together, allowing us to look at sales data at a more granular level. After grouping the data by item region, we use the sum sales aggregation function to calculate the total sales for each group. This allows us to determine the total sales value for each unique combination of item and region. The resulting data frame provides a summary of the total sales for each item within each region, giving us insights into the sales performance broken down by both product and location. Finally, we use the dot show method to display the resulting data frame, which contains columns for item, region, and the aggregated total sales sum sales. For example, item I in region 1 has two records with sales values of 10 and 30, resulting in a total sales value of 40. Similarly, item B in region 2 has sales values of 20 and 40, giving a total of 60. Item C in region 3 has one record with a sales value of 50. This example illustrates how you can use the group by function with multiple columns to group data by combinations of attributes such as items and regions, and then apply aggregation functions like sum to summarize the group data. By grouping by both item and region, you gain a deeper understanding of sales distribution across different regions for each item, which can be particularly useful for analyzing market performance, making data driven decisions, and identifying regional trends. 3. Using ag with multiple aggregation functions. In this example, we are working with a PySpark data frame D that contains sales data for different items. The data frame includes columns for item and sales. We use the created data frame function to create the data frame where each row contains an item and its corresponding sales value. This allows us to analyze the sales data and gain insights into how each item is performing. To perform a more detailed analysis of the sales data, we use the group by function in combination with multiple aggregation functions. By calling df.groupBy item, we instruct PySpark to group the data by the unique values in the item column. This means that all sales records for each unique item will be grouped together, providing a basis for calculating summary metrics. We then use the ag function to apply multiple aggregation functions to each group. Specifically, we use the sum function to calculate the total sales for each item and rename the resulting column as total underscore underscore sales using the alias function. In addition, we use the arg function to calculate the average sales for each item and rename the resulting column as average underscore sales with alias. This combination of sum and average allows us to get both an overview of the overall sales performance and a measure of the average sales per record for each item. Finally, we use the dot show method to display the resulting data frame, which now includes three columns: item, total underscore sales, and average underscore sales. For each unique item, we can see the total sales across all records as well as the average to sales value. For example, if item appears multiple times in the data, the total underscore sales column will provide the total sales value for all those records, while average underscore sales will show the average sales per occurrence of the item. This example demonstrates how you can use the group by function to group data by specific columns and then apply multiple aggregation functions to gain deeper insights into your data. By calculating both the total and average sales for each item, you can get a more comprehensive understanding of sales performance, which can be useful for identifying high performing products, analyzing trends, and making data driven decisions. The use of multiple aggregation functions with descriptive with this message output are more informative and easier to interpret. 4. Grouping and counting rows. In this example, we are working with a PySpark data frame diff that contains information about different items and their corresponding sales. The data frame has two columns, item and size, and we use the created data frame function to create it, where each row represents a specific item and its sales value. This structured data allows us to perform various analyses to better understand the distribution and performance of each item. To determine how frequently each item appears in the dataset, we use the groupBy function along with the count aggregation function. By calling df.groupBy item, we instruct PySpark to group the data by unique values in the item column. This means that all rows with the same item name will be grouped together, allowing us to analyze their frequency. Next, we apply the count function to each group, which counts the number of occurrences for each unique item. The result of this aggregation provides insight into how often each item appears in the data frame. This type of analysis is particularly useful for understanding item popularity or identifying how many records belong to each category. Finally, we use the dot show method to display the resulting data frame, which includes two columns, item and count. The item column shows the unique items, while the count column provides the number of times each item appears in the dataset. For instance, if item appears twice and item appears 3 times, the output will display these counts accordingly. This example demonstrates how the groupBy function combined with the count function can be used to analyze the frequency of different values in a dataset. By grouping by item and counting the occurrences, we gain a better understanding of the distribution of items, which can be useful for identifying trends, monitoring and/or analyzing item popularity. This kind of grouping and counting operation is common in data analysis for quickly summarizing categorical data and gaining valuable insights. 5. Filtering after grouping using having equivalent. In this example, we are working with a PySpark data frame diff that contains sales data for different items. The data frame has two columns, item and sales. We create the data frame using the create data frame function where each row represents an item and its corresponding sales value. This structured format allows us to analyze the data to better understand how each item is performing. To analyze the total sales for each item and filter out those that do not meet a certain threshold, we first use the groupBy function to group the data by the unique values in the item column. By calling df.groupBy item, we group all rows that have the same item value together. This creates groups based on each unique item, allowing us to perform aggregations on each group. After grouping the data, we use the sum sales aggregation function to calculate the total sales for each item. The resulting data frame will have two columns, item and zone. Sales where sum sales represents the total sales for each item across all records. To focus only on the items that have significant sales, we then use the filter function to filter the groups based on their total sales value. Specifically, we apply condition sum sales 50 to filter out the groups that have a total sales value of 50 or less. Only the items with total sales greater than 50 will be retained in the final output. This filtering step helps to focus on high performing items that have a notable contribution to overall sales. Finally, we use the dot show method to display the filtered data frame, which contains only the items that meet the sales threshold. The output will include the item column along with the sum sales column showing the total sales for each qualifying item. This approach is useful for narrowing down the analysis to only the items that have a significant impact, allowing you to focus on high value product and make informed decisions based on the most relevant data. Overall, this example demonstrates how you can use the group by function for grouping, sum for aggregation, and filter for selecting only those groups that meet specific criteria. It helps to derive actionable insights by filtering out less relevant data, enabling you to concentrate on high performing categories or products in your dataset. 6. Grouping and sorting. In this example, we are working with a PySpark data frame that contains sales data for different items. The data frame consists of two columns, item and size, which represent the name of each item and its corresponding sales value. We use the create data frame function to create the data frame, making it easy to structure and analyze the data for different operations. To analyze the total sales for each item and sort the results in descending order based on total sales, we start by using the groupBy function. By calling df.groupBy item, we group the rows in the data frame by the unique values in the item column. This step ensures that all rows with the same item name are grouped together, enabling us to perform aggregation functions on those groups. Next, we use the sum sales function to calculate the total sales for each item. This aggregation calculates the sum of sales values for each unique item, providing us with an overview of the total contribution of each item to the overall sales. The resulting data frame will have two columns, item and sum. Sales where sum sales represents the total sales value for each item across all records. After calculating the total sales, we use the order by function to sort the results in descending order based on the sum sales column. By specifying ascending falls, we ensure that the items are sorted from highest to lowest total sales. This sorting step is particularly helpful for understanding which items are the top performers in terms of sales, making it easy to identify the most valuable items at a glance. Finally, we use the dot show method to display the sorted data frame, which includes each item along with its total sales value sorted in descending order. This output helps highlight the items with the highest sales, allowing you to quickly identify the top contributors and focus on the most impactful products. It is especially useful in business context where you need to prioritize high revenue items or identify the products that are driving the most sales. Overall, this example demonstrates how the combination of group by sum and order by allows you to group, aggregate, and sort your data to meaningful insights. By sorting the items by total sales in descending order, you can easily understand the sales distribution and identify the most important items for your analysis or decision making. Thank you so much for watching. I hope this video helped you understand how to use the groupBy function in PySpark to group and aggregate data effortlessly. With groupBy, you can break down complex datasets into meaningful summaries and unlock new insights. If you found this video helpful, be sure to like, share, and subscribe for more PySpark tutorials. And don't forget to leave a comment below if you have questions or if there's a topic you'd like us to cover next. Until next time, happy coding and keep exploring the power of PySpark.